The plate storage area is a designated zone where steel plates are organized and stored before processing. Plates are stacked systematically, often by size or material grade, to ensure easy access. Plate handling by EOT cranes with magnetic lifters involves using overhead traveling cranes equipped with powerful electromagnets to safely lift and transport steel plates within the facility. This system allows for efficient, non-contact handling of heavy plates, minimizing surface damage and ensuring precise placement onto the production line or storage racks. Plate feeding to edge milling by vacuum lifter uses suction-based lifters to securely transfer plates for precise edge milling. The edge milling machine precisely removes material from the edges of steel plates, ensuring clean, accurate edges for welding. This step is crucial for achieving high-quality pipe seams. The crimping machine, SMS mirror, bends plate edges for forming. The U-ing press shapes the steel plate into a U configuration as an intermediate step in forming the pipe, preparing it for the subsequent O-ing press operation. The O-ing press completes the pipe forming process by bending the U-shaped steel plate into a fully rounded O shape, creating a cylindrical form. This press applies precise force to ensure the edges align perfectly for welding, which is critical for maintaining the structural integrity of the final pipe. Pipe washing one station cleans the pipe's surface pre-welding. The pipe drying station with burners uses controlled heat to thoroughly dry the pipe after washing. This step removes moisture, preventing oxidation and ensuring a clean surface for subsequent processes like welding. Continuous tack welding involves a specialized welding system that continuously applies tack welds along the pipe's seam. This process temporarily joins the edges of the pipe segments, holding them in place for final welding. System ensures consistent weld quality and alignment, critical for maintaining structural integrity. It improves efficiency by automating the tack welding process, reducing labor costs, and enhancing precision. The tack repair station addresses and corrects any defects in tack welds, ensuring uniformity and strength before final welding. Pipe numbering involves marking each pipe with a unique identifier, typically including information like production batch, size, and material type. This system ensures traceability throughout the manufacturing process, facilitating quality control, inventory management, and efficient tracking during further processing or installation. The ID welding station performs internal welding on the pipe's seam. This process involves applying a weld inside the pipe to secure the edges, ensuring a strong, continuous bond. The station is equipped with specialized tools and fixtures to maintain precision and quality, crucial for the pipe's structural integrity and durability. The ID welding station applies internal welds along the pipe's seam using specialized equipment to ensure precise, strong joints. This step is crucial for the pipe's structural integrity and durability. The tab beveling station machines the pipe ends to a specified angle, preparing them for proper fit and weld alignment. Pipe weld bead inspection. Pre-visual involves a preliminary visual check of weld beads for obvious defects before further testing. The ultrasonic testing machine, UST-1, uses high-frequency sound waves to detect internal flaws in the pipe. It sends ultrasonic pulses through the material and measures the echoes reflected from defects, such as cracks or voids. The mechanical expander enlarges the pipe's diameter by using a mechanical force to expand its walls, ensuring precise sizing and smooth internal surfaces, which is crucial for proper fit and performance. The hydro tester subjects the pipe to high-pressure water to test for leaks and structural integrity. This process ensures the pipe can withstand operational pressures without failing or leaking. Final ultrasonic testing, UST-2, conducts a comprehensive scan of the pipe to identify any remaining internal flaws or defects after initial processing, ensuring the highest quality and reliability before final approval. ID surface inspection examines the internal surface of the pipe for defects such as cracks, pits, or weld irregularities. OD surface inspection evaluates the outer surface of the pipe for defects like dents, scratches, or weld inconsistencies. This step is crucial for ensuring the pipe's structural integrity and appearance. Dimension check involves verifying the pipe's dimensions, including diameter, length, and wall thickness, against specified tolerances. This ensures the pipe meets design and quality standards. Accurate measurements are critical for proper fit and function in its intended application, as well as for compliance with industry standards and regulations.
The operation of a 3D fabric embossing machine involves precise temperature and time settings to ensure optimal results. Firstly, set the machine's temperature based on the fabric type and silicone ink specifications, typically ranging from 120 degrees Celsius to 180 degrees Celsius. Adjust the machine's time settings according to the complexity of the embossing design and fabric thickness, typically between 8 to 12 seconds. Proper calibration ensures thorough silicone curing and adherence to the fabric, resulting in high-quality, three-dimensional embossed patterns with durable finishes. The stroke adjustment between heating plates is a critical step in operating a fabric embossing machine. It determines the distance between the plates, accommodating varying fabric thicknesses. Proper adjustment ensures uniform pressure distribution during the embossing process, preventing fabric distortion or uneven embossing. Typically, the stroke can be fine-tuned based on the specific fabric being processed, ensuring precise contact between the silicone-coated molds and the fabric surface. Silicone and catalyst mixing is a crucial aspect of fixing molds on the heating plate and fabric prong in fabric embossing. It involves blending silicone ink with a catalyst in precise ratios to initiate the curing process. Thorough mixing ensures uniform consistency and proper curing of the silicone. Once mixed, apply the silicone catalyst blend onto the molds and fabric prong evenly. The catalyst triggers a chemical reaction, bonding the silicone to the molds and fabric upon curing. This ensures secure fixation of the molds and prevents shifting during the embossing process, facilitating accurate and repeatable embossed patterns on the fabric surface. Filling silicone on molds involves carefully applying the silicone ink mixture onto the male mold surface. Ensure even coverage to achieve uniform embossing results. Use a spatula or similar tool to spread the silicone evenly, minimizing air bubbles and ensuring proper adhesion to the fabric during the embossing process. During the fixing mold time of 90 seconds, the silicone undergoes curing, ensuring secure attachment of the molds to the fabric. In fabric embossing, positioning the male mold on the top and the female mold on the bottom ensures proper alignment and pressure distribution during the embossing process, resulting in accurate and consistent 3D patterns on the fabric surface. During the heating press time of 90 seconds, the embossing machine applies heat and pressure to the silicone-coated molds and fabric. This duration allows for proper curing of the silicone, ensuring durable adhesion to the fabric and precise transfer of the embossed pattern, resulting in high-quality finished products. To prevent fabric sticking on the mold, apply a thin layer of detergent on the mold surface before embossing. This reduces friction and ensures smooth release of the fabric post-embossing. Fabric embossing time typically ranges from 8 to 12 seconds, depending on factors like fabric type and thickness. This duration allows sufficient heat and pressure for the silicone to adhere to the fabric, forming the desired embossed pattern. Longer durations may risk fabric damage or over-curing of the silicone. Screen printing scrapers and printing frames are essential tools for applying silicone ink onto fabric. The printing frame holds the fabric taut, ensuring even application, while the scraper spreads the ink across the fabric's surface. Together, they facilitate precise and consistent printing, yielding high-quality results in fabric embossing. Printing silicone on the back side of the fabric involves using a screen printing setup. The fabric is securely held in place on a printing frame, ensuring stability during printing. Silicone ink is then applied onto the fabric's backside using a screen printing scraper, ensuring even coverage. This process allows for precise application of the silicone, ensuring that the embossed pattern appears on the front side of the fabric with clarity and definition. The Mark IX cigarette making machine stands as a testament to technological innovation in the tobacco industry. Introduced by the pioneering Rio filling systems, this marvel of engineering revolutionized the production of cigarettes, offering unparalleled efficiency, precision, and quality. Let's delve into the intricate workings and impact of the Mark IX, evolution of cigarette manufacturing. Before the advent of machines like the Mark IX, cigarette production was a labor-intensive process. Workers meticulously rolled and packed tobacco by hand, resulting in slow output rates and inconsistencies in the final product. However, with the introduction of automated cigarette-making machines, such as the Mark IX, the landscape of tobacco manufacturing underwent a profound transformation. Features and functionality. The Mark IX cigarette-making machine boasts a myriad of features designed to streamline the production process while ensuring exceptional quality. At its core lies a sophisticated mechanism that precisely measures and dispenses tobacco into each cigarette tube. This automated process eliminates human error and ensures uniformity in weight and density across every cigarette produced. Furthermore, The Mark 9 incorporates advanced sensors and control systems that monitor various parameters such as tobacco moisture levels, tube integrity, and cigarette length. These real-time feedback mechanisms enable the machine to make instantaneous adjustments, thereby maintaining optimal production conditions and minimizing waste. The versatility of the Mark 9 is another hallmark of its design. With adjustable settings, manufacturers can fine-tune parameters such as cigarette diameter, packing density, and filter type to meet the diverse preferences of consumers worldwide. Whether producing traditional king-size cigarettes or slim variants, the Mark 9 delivers consistent results with unmatched efficiency. Efficiency and productivity. One of the most remarkable aspects of the Mark 9 is its unparalleled efficiency. With a high-speed production rate that far surpasses manual labor, this machine has revolutionized the tobacco industry's capacity to meet consumer demand. The Mark 9 can produce thousands of cigarettes per hour, significantly reducing production costs and increasing overall profitability for manufacturers. Moreover, the automation provided by the Mark 9 enhances workplace safety by minimizing the need for repetitive manual tasks, thereby reducing the risk of occupational injuries and fatigue-related errors. This not only improves employee well-being, but also contributes to a more sustainable and efficient manufacturing process. Quality assurance. In addition to its impressive speed and productivity, the Mark 9 prioritizes quality assurance at every stage of production. Through precise control of tobacco dosage, packing pressure, and filter insertion, this machine ensures that each cigarette meets the highest standards of consistency and flavor. Furthermore, the Mark 9's integration with modern quality control systems allows for comprehensive testing of finished products, including visual inspections, weight checks, and smoke analysis. By upholding stringent quality standards, manufacturers can instill confidence in consumers and maintain brand integrity in a competitive market. Environmental considerations. While the tobacco industry faces increasing scrutiny regarding its environmental impact, the Mark 9 cigarette-making machine endeavors to address these concerns through innovative design features. By optimizing resource utilization and minimizing waste generation, this machine represents a significant step towards sustainable manufacturing practices. For instance, the Mark 9 incorporates energy-efficient components and automated shutdown protocols to reduce electricity consumption during idle periods. Additionally, its modular construction enables easy maintenance and upgrades, prolonging the machine's lifespan and minimizing the need for premature replacements. At Zavid Vic, the manufacturing process of our ventilation air deflector for residential buildings begins with the selection of high-quality galvanized steel, known for its durability and corrosion resistance. This material is crucial for ensuring the longevity and effectiveness of the deflector in various environmental conditions. Once the steel is sourced, it undergoes precision cutting and shaping according to the design specifications of the deflector. Our skilled technicians use advanced machinery to achieve accurate dimensions and smooth edges, essential for seamless integration into ventilation systems. Next, the formed steel components are assembled by our experienced team of craftsmen. Each deflector is meticulously crafted to meet our stringent quality standards, ensuring optimal performance and reliability once installed. Throughout the manufacturing process, quality control measures are implemented at every stage to identify and rectify any defects or imperfections. This rigorous quality assurance process guarantees that only superior quality air deflectors reach our customers. Hebei Jinshi Metals Workshop boasts advanced equipment, skilled personnel, and rigorous quality control for superior razor wire production. Raw materials include galvanized steel sheets for durability and high-carbon steel wire for strength in razor wire production. Blade punch forming involves precision punching of galvanized steel sheets into razor wire blade shapes, ensuring sharpness and uniformity. This process enhances the effectiveness of razor wire for security applications. In wire covering for razor wire production, high-carbon steel wire is tightly wound around the blade wire, enhancing durability, strength, and security of the final product. During clipping for razor wire, individual razor wire coils are securely bound together using metal clips to maintain integrity and strength.